Hi everyone! Let's review some scientific notation stuff. I'm just going to give a really quick rundown on this first chunk and then do an example for you. Remember that in scientific notation, we write a number. The number out in front is always between 1 and 10, and that between can include 1 but should not include 10. If you're trying to put a 10 out in front, that really means you need to up your power p once more and slide that decimal over one more time. So we've got some examples here, and mostly I'll let you look through them, but basically we're drawing attention to the order of magnitude of our number, how big it is, like what power of 10. So this P is our order of magnitude. So you can see some simple examples. If your number is already between 1 and 10, you would have a 10 to the 0 to force that scientific notation. Not really helpful in that situation, but if you really wanted to make sure it was in scientific notation, that's how you do it. Otherwise, you're basically taking a number and trying to hide any digits that are 0 and slide the decimal place over until there's only one digit in front of it. That's our big goal. So for example, with this 672 billion maybe, we want to slide that decimal over until there's only a 6 out in front, and then we're just counting how many times we had to move it. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and that's where the 10 to the 9 comes from. If you're moving it the other direction, as in this last example, we want it to end up with just the 7 out in front. We had to move 1, 2, 3, 4, 5, 6, 7, 8, 9 again, but this time we had to move the other direction. It was a small number, so that's going to be a -9. So the negative sign implies a direction that we're moving our decimal point, is one way to think about it. Okay, so let's just jump into doing a little arithmetic with this. This is why I have it in here. This is another one that our science teachers ask us to review. So when we multiply or divide numbers in scientific notation, are using our exponent rules. I don't have an example of this, but just to say it, if you want to add or subtract numbers in scientific notation, you're basically back to like terms. You can't add or subtract them unless the power of 10 matches up, at least not just easily in the way that you might want to. So either write them back in standard notation, add them, and then move it back to scientific notation, or if your powers of 10 already line up, then you can just go ahead and add them together. So it would be okay to say, in this case, since they're both 10 to the 6s, those are millions. So 2 million plus 3.1 million is in fact 5.1 million. But if one of those was a 7 or any other power, you'd have to be really careful. My goal is to practice some exponent rules in this context, so we'll look at multiplication and division. Our example is looking at the fact that the US consumes 97, I see thousands, millions, billions, trillions, quadrillions, a lot, BTUs of energy. In that same year, the population was about 285 million people, and we want to figure out the per capita energy consumption. So we want to divide. We want to know how much energy per person. So we're going to use our scientific notation to hopefully make this a little easier. We want to move the decimal place so that the 9 is the only digit in front of it. To do that, we've got to move 3, 6, 9, 12, 15, 16 places. So that will be a 9.7 times 10 to the 16. I almost said negative, but it's not negative. This is a big, big number. We want to do the same thing with the 285 million people. If you do enough of this, you're going to probably start to have memorized that millions is 10 to the 6. But I'm just going to write this out. If in doubt, write it back out. And here we can see that we need to move until the 2 is the only digit out in front, which is 3, 6, 7, 8 times. So 2.85 times 10 to the 8. And now to perform the operations here, I'm still probably going to have to go use a calculator to do the 9.7 divided by 2.85. But we can at least knock out the powers of 10 really easily. If we have 16 tens in the top and 8 tens in the bottom, we can cancel out 8 of those. That means they're all gone from the bottom, and there's 8 left in the top. So we will expect a 10 to the 8, and then this is just a calculator question, unless you get really nice numbers. What is 9.7 divided by 2.85? And I got 3.4035. I'm going to stick with the 2 decimal places. In your science classes, you'll talk about significant figures. I'm not going for that here. We had the 2 decimal places on the 2.85, so we'll stick with about that. Sometimes when you do this division, you end up with a number either smaller than 1, so there's a 0 out in front, which we don't want, or bigger than 10, which means there's 2 digits out in front, which we don't want. In that case, you might have to do one more step to move the decimal place over once, and you'll either have to add or subtract 1 from your power of 10. But a lot of the times you do end up with a nice operation here, a nice calculation that does give you a number just how you want it to be. And this would be BTUs per person. All right, so you'll have a little of this to play around with. Hopefully that goes pretty quickly and easily just to refresh your memory.